Okay, determine if each set of numbers can be measures of a triangle. If so, determine if the triangle is right, acute, obtuse. So first of all, when you are determining if each set of numbers can be measures of a triangle, you want to use the triangle inequality theorem. For instance, I have 5, 8, and 10. Write 10, 8, and 5 just like so. And then you're going to say, okay, what two numbers are not 10? Well, that'll be 5 and 8. So you're going to do 5 plus 8 and then compare that to the right hand side. So 5 plus 8, that is 13. Well, 13 is indeed greater than 10. Put a check mark. And then you're going to do the same thing. Here's 8. The two numbers not 8 are 5 and 10. And then you can see that 5 plus 10 is greater than 8. So put a check mark there. And then here's 5. So you have 8 plus 10, obviously greater than 5, so put a check mark. So that means since all the combinations do check out, you have formed a triangle. But you're not done. If so, determine if the triangle is acute, right, or obtuse. So I like to have c squared on the left hand side and then a squared plus b squared on the right hand side. If c squared is equal to a squared plus b squared, that means you have a right triangle. If c squared is greater than a squared plus b squared, you have an obtuse triangle. If c squared is less than a squared plus b squared, you have an acute triangle. So since we have a triangle here, what type of triangle is it? So what is c? C will be the longest side of the measures. So that's C, we'll call this A, we'll call that B. So A, B, C. Usually C would be the third number of the given measures. Okay, so we have C squared and then A squared plus B squared. So C is 10. So 10 squared blank. You have 5 squared plus 8 squared. So 10 squared is 100, and then 5 squared plus 8 squared is 89. 100 is greater than 89, so what type of triangle is this? Since the left-hand side is greater than the right-hand side, it is a obtuse triangle. So yes, it's a triangle and the type is obtuse. Okay, number 14. Well, this is fantastic. I said that, C would be the third position, but this one's not, so I guess the review fooled you and fooled me. So 14, we have 8, 20, and 4. We're gonna write 4, 20, 8. So since 4 is my main character, we have 8 plus 20. 8 plus 20 is going to destroy number 4. So check. 20, we have 8 plus 4. Is 8 plus 4 greater than 20? Absolutely not. 8 plus 4 is less than 20. So this does not check out. No, you cannot form a triangle with this one. Okay, number 15, we have 10, 8, and 7. So is 7 plus 8 greater than 10? Yes. What about 8? What numbers are not 8? 7 plus 10. So that will be greater than 8. Here's 7. 8 plus 10. That's greater than 7. So yes, you have a triangle here. So c squared blank a squared plus b squared. 10's the longest side, so 10 squared blank, 7 squared plus 8 squared, 10 squared is 100, and then 7 squared plus 8 squared, if I put that in my calculator, that's going to be 100, or not 100, that's going to be 113. Notice that 100 is less than 113, so this is an acute triangle. This is an acute triangle. Okay, number 16, 3, 4, 5. So 3, 4, 5. 4 plus 5 is greater than 3. 3 plus 4 is greater than, oh, sorry, not 3 plus 4. 3 plus 5 is greater than 4. And then we have 3 plus 4, that's greater than 5. So all the combinations do check out. That's a triangle. So now let's figure out A, B, and C. So C squared, A squared plus B squared. You have 5 squared, and then you have 3 squared plus 4 squared. 5 squared is 25, 3 squared plus 4 squared is 25. So the left hand side is equal to the right hand side. So this is a right triangle. Find the geometric mean between each pair of numbers. So you need to remember that it's x over a equals, or I believe it's a over x is equal to x over b. Yep, that's the right one. When you cross multiply, you should get x squared equals a times b, take the square root, x is equal to the square root of ab. Okay, and that's what we're gonna jump right into using this instead of, you know, writing this all the time or plugging it into this all the time. So let's go ahead and do that. So this is a, this is b, so it's x equals 12 times 3. So I'm gonna break down the 12. That's x equals 4 times 3 times 3. You have, well, 12 times 3 is a perfect square. So it's x equals root 36, or x equals 6. So 6 is the geometric mean between 12 and 3. So that's your answer. For 18, we're going to do x equals root 45 times 20. So x equals, well, what two numbers multiply together will give me 45, where one of them is a perfect square. 9 times 5. 20 would be 5 times 4. I have the square root of 9, which is 3. So 3 will go outside of the square root. So I don't need this anymore. I have the square root of 4, which is 2. So 2 will go outside. And then look at that. I have a pair of 5. So that means that that's the square root of 25, so 5 will go outside of the radical. So x equals 3 times 2 is 6 times 5, that's 30. So x is equal to 30. So 30 is the geometric mean between 45 and 20. Okay, I have 19. So this is weird because we have the square root of 20 and the square root of 80. So I'm going to call square root of 20 A, and I'm going to call square root of 80 B. So I have x equals the square root of square root of 20 times the square root of 80. So x is equal to the square root of the square root of 20 times 80. Let me go ahead and tell you that x is equal to the square root of 80 times 20, which is 1600. So x is equal to, well, the square root of 1600. 1600 is a perfect square, so that's 40. So that's 40, but we cannot forget the square root here. So x is equal to the square root of 40. Okay, so you're basically taking the square root of a square root. The square root of 1600 is 40, but since we have that square root remaining, you're basically taking the square root of 40 here. Okay, but this is not our answer because we have to simplify that. What two numbers multiply together that'll give me 40? Well, I'm thinking 10 and 4 because I want a number with a perfect square, which will be 4. So x is equal to 2 root 10. That one was a little tricky. Okay, so number 20, find x, y, and z. So you're dealing with a right triangle. So we're doing right triangle proportions. You're going to do Hills and Sass. So Hills and Sass involved. The one thing that I like to do is label. So across from the 90-degree angle, this is my hypotenuse of the original figure. Yes, I know this is the 90-degree angle. There's a 90-degree angle here, but I want to find the hypotenuse of this whole triangle, not this triangle here, okay? So this is the hypotenuse, and the hypotenuse is 4 plus 9, that's 13. And then this is segment 1, this is segment 2, that's leg 1, and that's leg 2. Because you called this segment 1, you need to be consistent, you need to call that leg 1. And since you called this segment 2 here, you need to make sure that you call this side leg 2. You cannot call this segment 1, and you cannot call that leg 2. You need to be consistent. So then, let me go and write my organizer out. So this is H, L1, L1, S1, H, L2, L2, S2, and then we have, I'm going to put segment 1, altitude, altitude, segment 2 there. Okay, the hypotenuse is 13, so I will put 13 here, 13 there. The altitude, oops, I forgot to label this the altitude. The altitude is Z. So the altitude is Z here, Z there. Segment 1 is 4. 4 here, 4 there. And then we have segment 2, which is 9. Leg 1 is X. And then leg 2 is Y. Okay, I'm going to focus on this. I can create a proportion using Sass here because we're dealing with one variable. So 4 over Z equals Z over 9. Cross multiply, so Z squared equals 9 times 4. Take the square root. Well, if I have 9 and 4, if I'm multiplying, that's going to give me 36, and 36 is a perfect square. So Z is equal to 6. For hills with subnotation 1, you have 13 over x equals x over 4. So x squared equals 13 times 4. Take the square root. You have the square root of 4, which is just 2. So x equals 2 root 13. Hills 2, you do 13 over y equals y over 9. Cross multiply, y squared equals 13 times 9. Take the square root. Look at that, you have the square root of 9. The square root of 9 is 3, so y equals 3 root 13. And that's your answer. Alright, so again we're dealing with a right triangle proportion. So whenever you see an altitude, when you have a right triangle with an altitude, you're going to do right triangle proportions. So again, we're going to label. This is the hypotenuse, that's 25. This is segment 1, this is segment 2, that's the altitude. This is leg 1, and that is leg 2. And just by looking at this, there's nothing here and nothing there. But we have segment 1, altitude, and segment 2. That looks like we're going to be using Sass. Right, so segment 1, altitude, altitude, segment 2. So I can plug that in. That's 9. This is x, that's x, and segment 2 is 16. 9 over x equals x over 16. Cross multiply, x squared equals 9 times 16. Notice that 9 and 16 are perfect squares. So really you're saying x is equal to 3 times 4, and that's 12.